In order for us to talk about annuities, the first thing we need to learn about is geometric sequences. If A and R are non-zero real numbers, the infinite list of numbers A times R squared, A times R cubed, A times R to the fourth, continuing it up to A times R to the n and beyond, is called a geometric sequence. So for instance, if we were to go ahead and let A equals 4 and R equals -2, then we'd have 4 times -2, 4 times -2 squared, 4 times -2 cubed, 4 times -2 to the fourth, and so on. If we were to work out those values, we'd have 4, -8, 16, -32, 64, and so on. What you'll notice there is there's a starting point, and every number after that is just the previous one multiplied by -2. So that number -2 is called the R value, or the common ratio. So the individual terms of that geometric sequence we listed out before, A times R squared, and so on. The first term is the A, the second term is the AR, the third term is the AR squared, and if we continue doing that, we always notice whatever the power is on the R is one less than what term that it occurs in. So when I get up to AR to the n, that must be in the n plus 1 term. So the nth term of the geometric sequence must be AR to the n minus 1. Because remember, the term, the power is 1 less than that. So if we're in the nth term, the power is 1 less, that would be n minus 1. Let's go ahead and find the 10th term of the geometric series 4, 12, 36, 108, and so on. So the first thing we need to do is to find the common ratio R. In other words, what number do we multiply the previous one to get the one after? The easiest way to do that is to go ahead and form the ratio between the two numbers. So 12 over 4, which is 3, or 36 over 12, which is also 3, or 108 over 36, which is 3. You can see why they call it the common ratio, because when I calculate out these ratios, I get the number 3. So that tells me that my R value is equal to 3. The first member of the sequence is 4, so that means that A is equal to 4. Now that I have those two values, I know everything there is to know about this geometric sequence, and I can go ahead and figure out what the 10th term is. The 10th term will be AR to the n minus 1. So the n in this case is 10, so I have to compute 4 times 2 to the 9th. And when I do that, I find that that 10th term is going to be 2048. That's a lot easier than continuing this series on and on and on. I can just go directly to the term that I want. So what we're going to be interested in doing with annuities is we're going to take these terms, the A, AR squared, and so on, and we're going to be wanting to add them up. If we want to add up the first n terms so that it starts with A and ends with AR to the n minus 1, we're going to call that S sub n, so the sum of the first n terms. So in the case that we had R is equal to 1, will be A plus A plus A plus A, n terms. So that means we have n A's there, so that's just n times A. If R is not equal to 1, then in order for us to figure out what that sum is, I'm going to apply a little bit of a trick. I'm going to take that original sum that we wrote out here, and I'm going to multiply both sides of that sum by R. Then I'm going to go ahead and take the opposite of that sum. So the opposite of S sub n is just going to be minus A, minus AR, minus AR squared, minus AR cubed, and so on. And what you'll notice is between R times S sub n and the opposite as S sub n, I see a lot of terms that are in common. They both have the AR squared, the AR cubed, and so on. So what I'm going to do is I'm going to add these together so that I have all those terms that were in common but have opposite signs. They're going to cancel out. What I'm going to be left with is the negative a and the ARN. So that tells me that R S sub n minus S sub n is just equal to minus a plus AR raised to the nth power. So all of those terms that I had there all cancel out. I'll notice that there's some things in common on each side. So let me go ahead and factor out the common S sub n. So I have S sub n times R minus 1. And I'll also factor out the a and rearrange the terms a little bit. So I have a times the quantity R sub n minus 1. We're looking for what S sub n is equal to, so I'll divide both sides by R minus 1. So I end up with S sub n equals a times the quantity R to the n minus 1, and in the denominator R minus 1. So if you tell me what that first member a is, what the common ratio R is, and which term you want, instead of just adding up all of those terms, I just need to stick the numbers into here, and that'll tell me what that sum is. So to summarize, if a geometric series has a first term a and a common ratio R, then the sum S sub n of the first n terms is given by the formula S sub n equals the fraction with a times the quantity R to the n minus 1 on top, and in the denominator R minus 1. So let's go ahead and use that. Let's figure out the sum of the first 8 terms of the geometric series. So I want to add these terms up all the way out to the 8th one and see what it comes out to equal. There's 8 terms here. It would be fairly straightforward to go ahead and list them out, but I want to apply our formula. So what I want to notice is that a is equal to 4 because that's the starting point. And if I take minus 8 divided by 4, or 16 divided by minus 8, or negative 32 divided by 16, I get that the common ratio is negative 2. So here's my S sub n formula. And now what I'm going to do is I'm going to put in the a and the r values, and n equals 8. So I get 4 times the quantity negative 2 to the 8th power, subtract 1, and in the denominator, negative 2 subtract 1. Working out the top, I see that the minus 2 to the 8th gives me 256. Further simplifying the top shows me that that's 1020. The bottom is negative 3, and when I divide that out, I get negative 340. So the sum of all of these 8 terms is going to be negative 340.